Okay, so I want to just step us through this activity on similarity primarily. So two triangles are similar if you can rotate them or reflect them or line them up in some way so that corresponding sides are proportional in length and corresponding angles are congruent. So, and this really just looks like one of them is like, where you zoom in on it, or where you like set it on the copier machine and you set it to copy at like 200% or something. That's what similar triangles are, right? So they are the exact same shape, but they just kind of like are bigger or smaller. Okay, so now this is really the definition of similar triangles, and it turns out showing that all of this is always true is hard to do, and we generally don't have all of the lengths of the triangles and all of the angles of the triangles in order to prove they're similar. We're trying to use similarity before we know those things or in order to find those things. So the three kind of really they're kind of theorems, but the three things were types of similarity we'll talk about are ways to have less information than all of this, but still conclude that triangles are similar. So angle similarity says that two triangles are similar if the corresponding angles are congruent. They're like corresponding angles are equal, right? So if I can show this, like all three angles, they all have pairs and they're all the same, then I don't have to show, then I get for free that the corresponding sides are proportional. I don't have to show that. It's definitely true that the triangles are similar. Okay, so here I'm going to draw the first part of the activity. It says below are two bases for two triangles. Triangle A, so we're going to draw this because I tried to get this in Word to do this and I just got frustrated. So let's draw these. So let's draw one that has a base of 1.5 inches. There's that one, and I'll draw this other one over here, and it's supposed to have 3 inches. Okay, so I'm going to just mark those. That's 1.5, that's 3 inches, and here's A and B, right? Okay. And then we need to make sure, so that's just the base of the triangle, and this is angle, so we're just going to make all of the angles equal. So I have my protractor here, and the protractor looks like this, right? And so I'll show you. Do you guys remember how to use a protractor? There's usually this little, like a center point. Sometimes it's a circle down here. Mine's just a line. So you line that up with the end of this line segment, and I'm going to line it up there. And then you have to carefully make sure the line stays close to the bottom, like against this ruler. If your line goes out far enough, you want to make sure it's lining up here. So for this one, I think it'll be long enough. Let me look. I'm going to put a dot here. So for this one, do you see I'm going to like scooch this up just a little bit so that it hits right at 0, the line that I have. Okay. So I'm going to put this here, and then I'm just going to mark, this is 60 degrees, and I know it's way out here, but I'm just going to mark it right here. Right? And, okay, so I have to, like, I'm just going to draw this line way out here, because really what I'm going to do is draw lines. The thing that I don't know is how long these lines need to be, so it doesn't matter, right? I'm going to draw like this. And that's one triangle, and this is my, oh, why did I do 60 degrees? That's not, all right, hold on. Erase that. That's not one of the angles. Gracious. That's in another problem. I think that's in part B. Okay, let's do 40 degrees. Okay, so I'm going to do this again. 40 degrees. Right there. Okay. And again, I'm just going to draw this line. That's what erasers are for. Okay. And now I'm going to draw this other angle. Let's say, how am I going to do this? Like, I want this angle to be, oh, I know, I can do it like this. So I can use, this is why protractors have these, so you can do this angle this way, right? So I'm going to put a dot here and line it up with this guy and make sure it lays flat along here. And then the other angle that I need to do is 75 degrees, which I think is right up here. I'm going to do that. I'm going to connect these. And then let's check this last angle. So I'm going to line this up one more time and check it. So now I'm going to turn direction and put this right here at this angle. I'm going to line this line up right there. And I'm going to try and see, I would like to see where this one is going. And you can really extend this if you need to check the angles, like people just extend the line past this triangle that I'm looking at. So let's see if this helps. There's that one. And it's right there, and it looks like it's at, ooh, it is off. Do you see that? So it should be at 65. Yeah. Should be at 65. Sorry, for a minute I was hoping it was not 180. So maybe one of these is kind of off. It's okay. Don't like, we'll pretend. But these are kind of off. But this also means if yours are off, the ratios that you do are going to be off. Okay, so let's do this other one. Okay, I'll let you do this other one. That's fine. Let's do it. Okay. So I'm going to draw this again. And again, I want these to line up. So this first one is 40 degrees. Right there. And I'm just going to mark this other one while I'm here. This one is... What's the other one? 75. 75 degrees. And then we'll check it. Maybe this one is better. Okay, and then let me check this one. Go. Oh, that's closer. That's better. That's closer to 65 degrees. Can y'all see that? There. Okay. Okay. So here's my 65, 75, and 40. Okay. So, and now you're just going to use your ruler to measure these. And I'm also going to look at page 2 because it says the directions are on page 2. So measure the lengths and then highlight these in green, blue, and red depending on which side it is. And then we're going to fill in this chart. So I'll show you this. So let me get my ruler out and I'll measure. We're just measuring the triangles, right? So I'm just going to measure those. So that looks like about 1.5 also. I'm just going to measure in inches. And then here it's really close to 1 inch. Okay, let me do this one. This one is 2 and 2/6, like maybe an 1/8, 2 and an 1/8. And this one is, let's see, 3 and an 8th, 3 and an 8th maybe. Okay, and then I'm supposed to color the shortest side in green. Let me see if I have green. Shortest side, oh, so there are 2 ones that are really close. But the shortest side I think is here. And then let's do the longest side in blue. I think this is blue. We'll pick this guy because it's the longest over here. And then in red, the mid side. But this is one way to line up which sides kind of are corresponding, because there's no way for the shortest side of one triangle to be connected to the longest side of the other triangle and for them to be proportional. So this is kind of one way to make sense of that. Okay, so now I'm going to fill in this chart. So shortest side of triangle A is 1. The mid side is 1.5 and the long side is 1.5. And then I get 2 and an 1/8, 3 and 3 and an 1/8. And then over here you'll do the ratio, what is an 1/8? Like 0.12, I think. So like maybe, so A to B. So this is 1 over 2.12. This is 1.5 over 3. 1.5 over 3.12. I think do that for but I'm doing that for memory, but if it's different on your calculator. And then do this division. 1 divided by 2.12 should be something. And then, okay, so find these ratios and then make these observations. Hopefully they're really close, right? So all of these are really close to about a half. Do you see that when I'm doing it? And hopefully yours are close to at least about a half, because we set it up originally to be a 2-to-1 ratio. And so this is the example of angle, angle, angle similarity. The only thing I did to construct these was make sure that the angles were all the same. And when the angles were all the same, I got, as a result, these ratios to be all the same. So this means I don't really have to know in advance that the ratios are the same. I can just know that the angles are the same, and then I get this kind of as a freebie if I know that other stuff. Okay? And then we'll do the next one. Okay, now we're talking about side angle side similarity. So side angle side says I don't have to know everything. So if you go back and look at these 2 triangles, like knowing everything is knowing all 6 pieces of information listed here and listed here, right? So I have 6 pieces of information, 3 angles and 3 sides. That's like a complete triangle, or sometimes called solving the triangle to find all of this. Then I have 3 angles and 3 other sides here. Now really, for the actual definition of similarity, I would have to know all this to make conclusions. And like this, these 3 theorems say you don't have to know all that, you just have to know kind of these 3 things, 3 correspondences, right? So instead of knowing 12 pieces of information, 6 from each triangle, really in all of these you need basically 6 pieces of information. Okay, so it cuts it about in half. So side angle side says if you know 2 sides and the included angle, 2 corresponding sides are proportional and the included angle. So I want to say this. It's this side to this side, and here's an included angle. So if you have like 2 triangles where you know this is proportional, this is proportional, this, and these 2 are congruent, then you get similarity. So we're going to build triangles that have this in common, and then we'll make observations about the other stuff, right? So I'm going to start again. Triangle A and B, these are always about pairs of triangles. So I have this triangle A, and I already drew this base of 1.5 inches. And it says I have another side that's 2 inches and an included angle that's 60 degrees. So I'm going to mark this, this is where I got this 60 degrees from. So I'm going to mark this 60 degrees. carefully. There. And I'm going to mark this 60 degrees here. 60 degrees. Okay. And so then I'm going to say for this triangle A, this should be 2 inches. There we go. And then for triangle B, it should be 4 inches, double, because I'm trying to maintain proportionality. Do you see that? Like I've created these so that they're double. But you could have chosen any multiplier, but I think even here, 4 inches is going to take me. Okay. So, and then these are the endpoints. I just want to say, like, I can't extend those or change the length of those. I have to keep this to the same length to keep these proportional. Do y'all see that? Okay. So, if I know this, and this is 60, and this is 60, then the theorem says, look, everything else is going to be the same. And you can kind of see why that is, because just knowing this angle and knowing that these two endpoints are set means I mean, you can just imagine, like, this has to be, this third line has to be right here, right? There's no other place for it to go. This third line has to be right here, right? And looks like that. So I'm going to measure those, right? So let's maybe do this. Okay, so I'm going to measure the lengths of the triangle. And then this is D. Is there a way to draw the third side so they're a different shape? My answer was no, because you could see that. Okay, I get 1. That's 7.5. Maybe here? These are 16ths, right? 1, 2, 3. Yeah, so 16. So maybe there's 8. Maybe 13. 1 and 13/16. I'm going to need my calculator in a minute. Okay. And this one is 3.5. 10, maybe 3 and 10/16. I'm hoping those are about double. Okay. So again, color the short side in green. Where are those colors again? Shortest side in green, which is this one, right? Longest side in blue. That's this one. And mid side in red. Okay, and then measure the remaining angles and label those too. So I'm going to just with my protractor measure here, line it up. This is going to be hard. I have to extend these to kind of figure out where they are. To measure these angles. The other triangle will be fine. Okay. So let's see. So here I get, I'm going to call that 75 because we're real close. But that's this one right here. 75. And then this one, which one am I measuring? I want to measure it this way. There we go. And I probably need to, sorry, I extended the wrong one. I gotta extend this one so I can see it. Okay. This one I'm gonna measure right down here. Hold on, I'll show you so you can see. I'm off screen. This one I'm gonna measure, it's right there. It's like 45. Okay. Do you see that? Okay, now let's do these other two angles. So this one, there, that one is like, it's real close to 75. And then we're gonna do this one right here. And that is, it's more like 40, I think more like 47, or 6, 47, 48, something like that. Okay, very close. Do you see that? And like, if I was drawing these perfectly, they would be exact. So I just want to say that, but that's where we are. Okay, and so then kind of similar, do these, make observations. The sides should be about proportional. The angles should be the same. They should be congruent. And then answer the following questions. Is that okay? Okay, and these are reflection questions. Right answers, and we'll talk about them. So two triangles are similar if they have side angle, side similarity. So if I just know those kind of things, like I have these pairs of information, then I get all of the rest of the stuff that I didn't create, right? So if I have side angle side, then I know all of the sides are now proportional, or all of the angles are now equal from that small piece. So it's a way to take, like, again, a small piece of information and get more information, right? It's like, this is the bare minimum that I need to know, and then really it gives me the whole thing. Okay, so and then there's a final one, side, side, side similarity, which we'll do in a second. Okay, one more, which is side, side, side similarity. And like side, side, side is the hardest to construct, but I want you to understand what we know, or what we have to show, and what kind of direction this moves. So anyway, again, the true definition of similarity means that you know, and I'm going to show this again, like all 12 pieces of information, you know that like each angle has a corresponding angle that's equal. So the pairs of corresponding angles are congruent, and then pairs of corresponding sides are also proportional, right? So to me, you need 12 pieces of information, and you have to put them in a one-to-one correspondence and show that they have this relationship. Okay, so it's pretty complex. In side, side, side similarity, the only thing we have to do is we don't have to know anything about the angles. We have to know that all pairs of sides are proportional. So we have to know all 3 sides of triangle A and all 3 sides of triangle B, and then we have to know that they're proportional in pairs, right? Okay. So, and if I know that, if I know the pairs of sides are proportional, all 3 of them, then I don't have to even measure the angles. I know the angles are congruent. Like, that's just a byproduct, right? Okay, of this sort of similarity. So we're going to create 2 triangles that have 3 pairs of proportional sides. So I'm not going to do anything with angles. I'm not going to measure them or figure them out. So I drew a triangle, and part A says draw one triangle any way you want. I did use a ruler to do these. Do you see how this is 1 inch and 2 inches? So it's easy to double, and then I just measured what this was. But I didn't measure the angle, I just did it. It's just like random that came out. I was actually trying to make it kind of weird, and then it came out to be almost a right triangle. So I don't know what was happening. Okay. So I have this. And so then I'm going to create 3 sides. Now, okay, so this is the thing. I don't know anything about the angles. So I really can't. The thing is, it's really like you have 3. I just made this on a strip of paper. Do you see that? But I made it a length. I measured 3 inches, which is double this 1.75, right? Well, that's not double 1.75. Hold on. Let's do, I made that wrong. Okay, hold on, I'll show you how I make it. Okay, so 1.75 doubled is a little bit more than 3.5, right? Let me see if this is good. Oh, look how close this is going to be to 3.5. I think this is going to be perfect. 3.5 inches. That's good. Okay. So that's for that's double 1.75. And then I have these other two, double of 2 inches is 4. And then I have this one, right? And that's really what I know. I know that there is another triangle and it's put together in some way, but I don't know necessarily that it looks the same. So I don't necessarily know, for example, that this angle is really close to a right angle. Maybe I can put it together like this, right? So, but the goal is to take these three. I'm going to tape down this 3.5 inch one so you can see. I'm going to tape that so that it stops moving around. And that, again, really has, but I get to rotate these in whatever way that I want to, as long as the endpoints meet. That's it. So I need to rotate them so that they line up, but that's it. And you can try, the goal of this activity is try and do it so that they do it in a weird way and don't do it like this. And the answer is you can't do that because this is a form of similarity. So I'm going to put this right there. I'm going to put this right here. Let's line them up. Okay, I think that's close. Get another piece of tape. Should have torn this before doing this. There's that one. I'm going to get one more. There we go. Okay. And now I'm just going to measure all of the angles. I will let y'all do this because I think you know how to measure these angles by now, but measure all 3 angles on this one. Measure all 3 angles on this one and show that's where you can put them right here, and they should be really close. You should get that the angles are really close, and there you get this conclusion. Side, side, side similarity means if I know this information about the sides, just this side and this side is proportional, this side is proportional, this side is proportional, this side, then it will give me that the angles are equal automatically.